name's Robert Joachim Encinas. Today I will be discussing about the basics of pointers in C and their uses. Before we can begin talking about pointers, I think that it's best that I first talk about a way to visualize how variables work. This view of how variables work will make it so that pointers become much more intuitive later. You can think of a variable as being composed of three things: the variable name, the value, and the address. The variable name is simple. Just as the name implies, the variable name is the name that we use to refer to the variable. In C, the variable name can be found after the data type. When we use the variable name, C automatically retrieves the value that is associated with it. The value of a variable is the data associated with it. This can take on the form of numbers or characters. Lastly is the address. For the most part, the address is not something we work with regularly. Well, at least not consciously. The address refers to the physical memory address that the variable is given by the computer to use to hold the value. Now that we have defined this model of a variable that this tutorial will be using to make pointers more understandable, we can now finally get into what pointers actually are. Simply put, pointers are actually just variables, but instead of holding the typical number or character, pointers actually hold the address of other variables as their value. Let's visualize this with an example. Say that we have an integer value. This integer value is something we'll call x, and we make it a pointer variable called y. When we make y hold the address of x, we can say that y is pointing to x. You may have noticed from this example my use of an asterisk right after the keyword int. This is actually how we declare pointer variables, at least in C that is. To make a pointer variable, we just type the data type of the variable that we want the pointer to be pointing to, and then add an asterisk right after it. You can choose to put the asterisk right next to the data type or one space after it. Both work. I just personally prefer putting the asterisk next to the data type to reduce ambiguity. Now, because pointers hold an address instead of a value, it would be a bad idea to give it a value that we thought of, like, say for example, making the pointer y be equal to 0. Instead of doing this, we instead assign it the address of the variable that we want it to be pointing to. In this example, we can see that y is assigned the value of $x. The ampersand here is actually a special operator called the reference operator and can be read as address of. So $x would be address of x. With this way of reading this line of code now makes much more sense. Y is equal to the address of x. So with this, we know that y is pointing to x. We can make pointers now, but it's still kind of useless if we can't actually get the value of the variable that our pointer is pointing to. For that, we need the second special operator called the dereferencing operator, which is an asterisk that you put before a variable name, similar to how we use the ampersand operator. This dereference operator can be read as value of the variable pointed to by. Using this way of reading it, asterisk y would be read as value of the variable pointed to by y, which would be x. You can see that this is the case when we print out the values. Now, this is great and all, but what exactly is the point of learning pointers? There are actually a lot of reasons to use pointers, like the three examples on screen right now. We will not actually go too much in depth for the latter two examples as this tutorial assumes that the viewer is only at the level of someone taking CCPROG1 currently, and these two are far more advanced than Introduction to Pointers. As such, we will focus first on the first one. Now, you might be thinking, how exactly does a pointer allow for you to update multiple variables in a function call? Well, first, we need to understand how C actually handles functions and the parameters that get passed into them. When we normally pass variables as a parameter to a function, any changes we do to these variables inside the function doesn't actually affect the variable passed as arguments. This is because when we pass variables into a function as parameters, we don't actually use the variables that we passed in. Instead, we use a copy of the values of these variables that we passed in. This actually makes a lot of sense because when you pass variables into a function, you don't want it being changed out of nowhere when we do operations and functions. We can actually see this in action when we print out the addresses of the variable in main and then compare them with the addresses of the variables in the functions. Now that we can see that both of them have different addresses, this means that anything we do to this variable in the function, it will never reflect back on the original variable in main, because we're simply changing two different things and they're not linked in any way. Now, this is actually where pointers come in. Remember that pointers are just variables that hold addresses instead of the regular values. With this, when we pass pointers as the parameters, the value still gets copied, but instead of having just the value of the variable, like say an integer 1, be copied, we now have the address of the original variable in main. This means that when we dereference this parameter using the dereference operator, we are effectively calling the original variable in main. To show this, we can print the addresses again. Notice how the pointer passed as a parameter in the function has the same address as the variable in main. Since both the parameter in the function and the original variable in main have the same addresses, when we dereference the parameter and we change its value, we're actually changing the value of the variable originally in main, because unlike the first example, in which we only passed the variable and the value of that variable got copied, those are two different things, as you can see by the addresses. But here, since they both have the same address, changing one changes the other. Using this, we can change as many variables that we passed into the function as we want. Now that we have the theoretical definition of this out of the way, we can now actually start saying some terms that is used in the industry. First, when you have a function where you pass in a value, that is, you're passing in something that is not a pointer, this is something we call pass by value. In short, we are passing only the value of the variable instead of its address. If we pass the address instead, we're doing something called passing by reference. And as the name implies, we're not passing a value, we're instead passing a reference to the original value. Now that we have all of these terms and concepts out of the way, we can now finally see some examples of using pointers for functions. We can see here from the function called swap, this is a function that uses non-pointer variables a and b as its parameters. First, we make it a temporary variable that will hold a for a bit, because we will override a with the value of b here, and then with b, we will now give it the original value of a that we stored in the temporary variable. We can see here that the original values are x equals 1 and y equals 2. And when we print it before the swap here, we can see this. The value of x is 1 and the value of y is 2. It's consistent with what we do here. But when we do the swap function, let's just hide this for a bit. When we do the swap function and we print it out, you'd think that x and y would be swapped because they were swapped here, but actually they aren't. Before the swap, it's x equals 1, y equals 2, and after the swap, it's still x equals 1 and y equals 2. Why is that? Again, we need to remember that we only passed the values of a and b. We didn't actually pass their addresses. So what a and b here are just copies of the values of x and y. But we can see that if we print the values of a and b in the function, oh, sorry, it was highlighted. We can see that it actually did swap in the function. It just didn't reflect in main. Now, this is where we will apply what we learned earlier, which is passing by reference. When we make a and b pointers here, by adding the dereference operator in front of them, we can now see that it actually does the swap correctly. Oh, there. It raised an error because we didn't actually pass in addresses. We passed in the integer values of x and y, which resulted in a warning. Now, it should be correct. We can see that before the swap, it is correct. It's still x equals 1, y equals 2, just as stated in line 12 and 13. But when we print it inside the swap, it does it correctly. It swaps the two variables, x equals 2, y equals 1. And now we can see that after the swap, it did actually change, because we actually changed x and y here since we passed in their addresses here, so when we dereference A, what we're actually doing is we're calling X here, and when we dereference B here, what we're doing is we're actually calling Y here. So even if we remove this, it now works as intended. Now, you may ask, where do we use swap functions? Well, swap functions are actually very important in programming as the swap function is actually the basis of algorithms. Important ones such as the sorting algorithms, bubble sort, insertion sort, all of them use the swapping algorithms to put the elements of an array or a list in their proper positions. We'd like to emphasize that this tutorial is only scratching the surface of what pointers can do in C. As you can see from the title of this video, this tutorial only covers the basics of pointers. But to satisfy curiosity, the second use case mentioned earlier, allow for special data structures, are exemplified by things like linked lists, which use pointers to point to the next or the previous entries in the linked list. For the third use case, dynamic memory allocation, it allows you to have finer control over the memory that your program uses so you can optimize it to a great extent. Additionally, memory allocation allows for the creation of expanding and shrinking array or lists in other programming language. An example of this would be array lists that are present in Java. Now, that concludes this video tutorial. Thank you for watching.